Yes. Hey.
Hey guys, we're waiting on 2 more people. Almost there. Okay, guys, so let's get started. To start, we have a question on compound inequalities from someone in person. So, what's your question?
When exactly do you flip the sign?
When exactly do you flip the sign? So, if we're looking at something that looks like this, then I'm sorry, not equals. less than or equal to.
Teresa, cut your mic off.
Huh?
Cut your mic off.
I get it. And the camera? Putting me on blast like that?
How?
Okay, so when we have a problem like this, and we go to solve it, gotta mute that.
How?
Click the mic that says mute.
Where?
You're dumb. Hey, look, there's Mr. Al. He muted it. You're messing up our meeting. We only got like 40 minutes.
All right, cool.
Let's go.
Why you cut the camera off?
What? How did you turn back on?
Don't turn it back on.
How did you turn back on?
Okay, so back to this problem. We have negative 2x plus 3 is less than or equal to 4. So we subtract our 3 across, and we, when we do that, we get 1 on this side, and we get 0 over here. Minus 2x plus 0, so we can just erase our plus 0, is less than or equal to 1. So when we divide by negative 2, this is when we flip the sign, because this negative is being divided across, so it's changing sides. So now we cross this out, we flip our sign, we end up with x over here, negative 1/2 over here. So that is when you're flipping a sign. Does that make sense?
Mm-hmm.
Okay. Another question on that? She is looking at the homework.
Oh, the little, okay, so one of them you have a closed circle and then you have a line with the arrow.
Mhm.
And then one of them you have 2 circles, like a segment.
Okay.
And it stops.
So
Where do you use those?
she asked when you have something that looks like this on the number line, well, let me color this a different color just so it's visible. Something like this versus something like this. Correct?
Correct.
Okay, so this first example is going to be something like this that we just worked. So when you have one term, or one, like only one expression, such as x is greater than or equal to negative 1/2. This graph would actually look exactly like this if you replace that 2 with negative 1/2. So this is that graph. But on this one, you would have something a little different. This is when you have an and. So if you have x is less than or equal to negative 1/2 and x is greater than or equal to negative 4, then, and you have an and between them, then you can go to graph this by plotting your points, and you say, okay, x is less than negative 1/2. And negative 1/2 is further to the right on the graph because it is closer to 0 than negative 4. So we're going to put negative 1/2 right here. And then we're going to put negative 4 over here. And we say, okay, x is less than negative 1/2. So anything this direction, we're good to go. And we say x is greater than negative 4. So anything this direction, we're good to go. And it has to meet both conditions. So as long as it does, then we're good to go. So technically this negative 4 goes all the way over here and keeps going. It looks like this, starting at negative 4. And the negative 1/2 starts right here and goes all the way this way forever and ever, just backwards of the 1/2 thing. But when you say and, you have to meet them in the middle and where they overlap. So the only time you're going to have something that looks like this is when you have an and, or when you have a x is something like that, because that is pretty much just saying and. It's just a shorter way to write it. Does that make sense? At least when you're going to use each one of them?
I think so.
Okay. Does anybody else have any questions on compound inequalities? Okay.
Can we work one of the problems on the whole?
Sure. Give me an example, or give me the problem. We're working an example problem.
Let's see the part one. Okay, let's see. We're gonna do to 5k plus 3 is less than or equal to negative 32, or negative 4k plus 7 is less than negative 29.
Like that?
Oh yeah, I said it correctly.
Okay. Awesome. So when we start this, we're going to just pretty much divide the problem in half, right on this or. And we're going to work each one of them individually and then put them together at the end. So the first thing we need to do is get k by itself on each side. So I'm going to start on this left side and I'm going to subtract 3. So when we do that, we get negative 35 is less than or greater than or equal to 5k. So now we divide by 5. It's not a negative, so our sign stays facing the same way. So we end up with k is less than or equal to negative 7. And then we still have our or. And then now we solve this one on the right. So we do it the same way. We try to get k by itself. So we're going to subtract our 7. We're going to get negative 36. This is just going to give us plus 0. So now we have negative 4k. Okay, so now we're dividing by our negative 4. So we divide by a negative, so we flip the sign. So I'm going to start by doing that. So now we do 36 divided by 4, which is 9. So we end up with positive 9 over here because our negatives cancel each other out. And we end up with k over here. Okay, so this or sign tells us, it doesn't really tell us a lot with these types of problems. It just means it could be either one, so we need to graph both. It doesn't matter if they overlap, we just put them on the graph and that's the answer. So we draw our graph, if I can get this thing to stay still. And we put our 2 points on it. So we've got a negative 7 over here and a positive 9 over here. And you can put the little dots between these and be sure they're the correct number apart, but I'm not going to do that because it doesn't really matter about any other points. Just it matters that negative 7 is on the left side of 9 because it is less than it. So now we say, okay, k is less than or equal to 7 is the bigger number. The alligator up here is eating the negative 7. So we know that k is on the left side of it. So when we color this in, we're going to be working over here. That is where our graph goes. And since we have the or equal to mark here, we're going to use the closed circle instead of the open circle. If we just had this, then we would use the open circle. But since it is extra mark, extra dark. So, or k is greater than 9. So k is the bigger number because the alligator is eating k. So we know that k is bigger than 9. So we're dealing with over here. So now again, we have the line. So we're putting a closed circle. And this would be your answer. If instead we had an and right here, if I could get it to show it. If we had and here, then we would still graph it the same way, and then we would look at it and we would say, okay, where do these guys overlap? And the answer is they don't overlap anywhere. So there's no solution. But with or, it doesn't really matter if they overlap. We're saying, okay, it could be this or it could be this.
So what's the set notation?
Set notation is this. So we're going from the leftmost point on the graph. And the leftmost point on our graph is technically not on our graph. It's negative infinity. It's all the way left because we've gone less than negative 7. So we've gone all the way to negative infinity. So we put negative infinity, and we put a comma. We say, okay, 7, because, or negative 7, because that is our rightmost point of that part of the graph. And we put a bracket, because brackets go with closed circles. Brackets greater than or equal to, less than or equal to, they all go together. So we're just saying with this, it goes from negative infinity all the way to negative 7. Anything between those 2 points is okay. And then for this over here, we still have to include that. So we say or we just write it again. So I'm going to use a bracket with our number because it's a closed circle and a greater than or equal to 9 infinity because it goes all the way to the right.
If it had a 7,
No, it would not. So if we were dealing with something like this between these two, then we would write that as negative 7 bracket 9 bracket because closed circle on each end, and we're dealing with between the two. So we're just saying it goes from negative 7 to positive 9. Does this make sense?
why did you use the parentheses again?
The brackets go with this. They go with the closed circle and the underline. If you just have this or you have an open circle or any of the above, use a parenthesis. So with parentheses, you also, or with infinities, you also just use parentheses all the time. Does that make sense? So just to reiterate, if we had something that looks like this, okay, so we go to graph this. We draw our graph. And we put 2 on it. And then we put 7 on it. And we say, okay, X is between these two because that's pretty much what this means. When they line up like this and they all face the same direction and X is in the middle, that just means that X is between them. And it goes in this order. So 2 has to be the least and 7 has to be the most. So we're saying, okay, X has to be bigger than 2. So we're dealing with just this by itself to start with. So X is bigger than 2. So we're using an open circle because we don't have the less than or equal to sign right here. We're just dealing with less than or greater than. And then we color in a little bit this way. I'm just going to do that just so that way when we get to the second part, we don't have to erase anything. So now we're dealing with X is less than or equal to 7. So X is less than or equal to 7. So X is on the left side of it. So I'm going to use a closed circle here because we have the extra mark here. And now we say X is less than, so it's to the left of it. So now we meet them and we end up like that. So when we go to write this in set notation, all set notation is just saying this is the leftmost point, This is the rightmost point. Anything between them works. So we're going to use a parenthesis because our 2 is an open circle. And now we're going to put 7 because it's the rightmost point. And then we're going to use a bracket because it's a closed circle. So parenthesis, open circle, greater than 7, closed circle, bracket, and greater than or equal to. Does that make sense? Vaguely? I'm going to move on if I don't say anything. Okay. Let's move on to linear inequalities. So these were just inequalities in one dimension, meaning that they were on a number line. We're about to start linear inequalities on a graph with an x and a y axis. And these are not that much more difficult. Your shading is going to be a little different, but that's pretty much going to be it. So if we look at something like this, then we should go to graph that. Our first step is always to graph. And we can do that using our slope-intercept form. So I identify the slope right here and the y-intercept right here. And the slope just tells me rise over run, and the y-intercept tells me how far up or down I am on my graph. So when I make my graph, I do this. And then I go down 4, 1, 2, 3, 4, and I plot a point because that's my y-intercept. I got that from right here. Because it's negative, we go down. And you're always going to go on this line. So now my slope is 2 or 2 over 1. Because when you divide something by 1, it's the same as that number. And we want rise over run. So we are rising 2, 1, 2, and running 1. So this is our next dot. Now we've got a line because we've made 2 dots, and that's all it takes to make a line. And now we're going to do something to change this. We're going to, instead of an equal to that we've known how to do, we're going to do a less than. So we say y is less than this that we've just graphed. Well, what does that mean? Does it mean that it's down here? Does it mean that it's over here? Does it mean that it's up here? Well, that's what the inequality part of it is. And for inequalities like this, you graph your line first, and then your next step should be to drop something on your line from as high as you can go. So I'm literally going to draw a line from up here all the way down. So where this line is, where it hits, is the upper part. So this is the greater than section. This is the less than section. Anything that the line could never touch, no matter where you dropped it, is the less than section. So for your homework, what it asks you to do is take something like this and then shade it properly and draw the correct line and all that kind of stuff. So what it gives you options for are dashed lines, which we actually do use in this case, because it's just like the extra mark, extra dark thing. With just this, the less than, we use a dashed line. Is this making sense so far? It is kind of weird.
This is recorded?
Yes.
Okay, good.
Okay, so to reiterate, when we graph these using slope-intercept form, which you guys have seen before, correct?
Last year.
Okay. So slope-intercept form is something that you are familiar with. I think we're going to go over it in a minute, though. So we're going to hit it again. And with the inequality, you treat it just like an equal sign until you get to the part where it's time for shading. And when it is time for shading, you know that This goes with a dashed line, and this goes with a solid line. So just when you're drawing your regular line, like this, you know whether to use dash or solid. And then when you are determining where to shade, because you're going to have to color in, what you do is you drop something on the line. Just think of it as dropping a ball on the line. And anywhere that the ball could hit, because this line keeps going up and up and up forever and ever. So there's no way we could ever get the ball down here. It's kind of like below the ground. And it doesn't matter what the line looks like. If the line looked like this, then when we drop something on it, we're going to drop it right here. And then this is going to be the less than portion. So working another one. Let's work y equals.
Is this on the homework?
I do not know, honestly. I made these notes for Wednesday.
What lesson is it?
Again, I don't know. I know it is something that we're covering this week.
Probably 104.
Y is less than or equal to 3/4 times x plus 2. Okay, so to start, we graph our line. So we just graph it exactly like normal. So we go up to 1, 2, and we put a dot. I'm going to put it in a different color just so it's easier to see. And now we use our slope, our rise over run, to go up 3 and over 4. 1, 2, 3. 1, 2, 3, 4. So now we have a line because that's all we need to make a line. So trying to make this perfect. Okay. And we know that we're using a solid line because we have this greater than or equal to sign right here, or less than or equal to sign. So because it is equal to as well, we use the solid line. If it were just less than, we would use a dashed line. So from here, we need to shade. So we're dealing with y is less than or equal to. So y is on the lower end. So we drop something on our graph to determine which one is upper and which one is lower. So this is the upper section because we can hit it with the ball. And we need something that is less than our graph. So when we shade down here. So it's saying anything in this section will solve this correctly. Anything that we plug in, if we plug in this point, then it is going to work in this equation. It is going to be, our y will be less than 3/4 our x plus 2. So let's work one more where you guys work it. And then I will go over it when you guys get finished. So y is less than 3x minus 4. So give that a shot and let me know when you're finished. To what? Oh, I'm sorry. Gonna make them go away for 1 second. There you go.
Alright, when you're doing your graph, you start like, you graph the B first, and then do you start at the bottom back from the origin to graph your rise of run, or you start where the B is?
So that was a good question. To graph, you start by graphing your B, or your -4 in this case. And then she asked if you start from the origin to graph your rise over run, or if you start from where you put that dot. And the answer is you start from where you put the dot. So start from -4 when you're graphing your rise over run. -4 goes on the y-axis because it's your y-intercept. All right, y'all got an answer?
I think so.
Somebody virtually, do y'all have an answer? Maybe not. Okay, so what do you guys got?
I got. What do you mean?
Let me work it.
Oh,
I realized how dumb that question was when I asked it.
I was like,
okay.
which was that number?
So first, I plotted the -4.
Okay,
It is in a negative spot, so you go down, right?
yep,
Yeah.
right there.
So down 4, yep. And then what you're gonna do is you're gonna put a 1 underneath that 3, so you can get to a fraction. And you're gonna go up 3, starting from that point.
Okay, we're gonna go, I'm talking for the virtual people as well. So we're gonna go up 3, just so we can do that rise over run.
And then you're gonna go over 1.
And then over 1 for the run. So we put a dot.
And then 2 points, so you can make a line, but you need a dotted line because there's no, thingy underneath that thingy.
Okay, so she says that we use a dotted line because there's no equal to under this. So I drew my regular line, and now I'm going to erase parts of it. So that way I can make it dotted.
And then you need to start from the top of your line.
Okay,
So
so
you can know what's the greatest and what's the least.
now we start from the top and we drop something on it.
All right, and then it says y is less than, so you're gonna shade underneath that dotted line.
Okay,
Close by your point where you put -4 at, over there in that area, because that's underneath it.
okay. So she says because this is y is less than, we know that it's less than our line. And less than our line, we've just determined from right here, from dropping something on it, is down here. So we shade that section of the graph. So that is what we should look like. And then we can erase our little something that we dropped on it. And this dropped on it trick is not something that most people will tell you. It's something that I kind of came up with to help me remember it because I never remembered which side was positive and which side was negative. So just a little helpful trick. So that's exactly right. That's how you approach those problems. That's how you deal with them. I mean, you know how to graph rise over run and things like that. So,
Just like that.
well, we are good to go on that section. So moving forward, we're going to talk about piecewise functions. And piecewise functions sound scary, but they are really not. What they look like is this. If we have a line that starts here and goes to right here, we have an open circle. Then right here, we could have a closed circle, and then we could have this line. So this is a perfectly valid graph, but it's not, you can't really write it in one equation. It has to be more than one equation, because this line has a graph, or this line has an equation, and this line has an equation. So how you see this usually is something like this. F of x equals,
That was my next question. Why did they put F?
I'll explain that in just one second. 2, actually, I will do 2x plus 3, x minus 4. So I use little curly braces, even though they're bad. So for x is less than 2, x is greater than or equal to 2. Okay, so this is really just you graphing two different equations, and you're limited by what x's you plug in. It says, okay, if you have an x and you plug in 7, you can pick any x still, but if you plug in 7, this tells you which equation to use. You're using different equations based on which x you plug in. So if we say x equals 7, then we need to look up here and figure out which category it falls into. So we say x is greater than or equal to 2, so it's definitely in this category. 7 is definitely not less than 2. So for this, we would plug it into x minus 4. So if we had negative 40. So now we're looking up here and we're saying, okay, is negative 40 less than 2? Yes. But is negative 40 greater than or equal to 2? Definitely not. So we know that this is the equation that we're going to use because it falls into that category. So now we know that we're using 2x plus 3. So same thing, sorry, this is negative 40. So now we can do this for any number. You know, we have 0. So is 0 less than 2? Yes. So it goes in this category. So really 2 is where it changes. So that's where it flips. If we were to say, okay, what happens at x equals 2? Well, is 2 less than 2? No, it is not. They're the same. Is 2 greater than or equal to 2? Yes, it is, because of the equal to. So we are using this one for 2. So x minus 4. Now, when we go to graph this, I'm going to use this same graph. We graph each of these equations at different points on our graph. So up to 2. So up to, I'm just going to put a red line right here to know, so that way we know where we stop. So from there left, it's going to be this equation. And from there right, it's going to be this equation. So let's graph each one of them. 2x plus 3. So we need a plus 3. I'm going to put a blue line. 1, 2, 3. Dot. And then we need 2. So rise 2, run 1. So now we have a line. So it's going to look something like that. I know my line's not perfect. We're going to have an open circle here because we are using an equal to, or not using a greater than or equal to sign. So now we've got that, so we can erase this. Actually, I'll keep it there just for one more second. So it still divides our problem in half. So now on this side, we need to graph x minus 4. So x minus 4 has an intercept of negative 4. And we're going to work on the left side of the line for right now, but I'll show you how to transition over in just 1 second. 2, 3, 4. And then we have a rise over run of 1. So we're rising 1, running 1. Rising 1, running 1. So drawing our line, it looks like this. Now, this is okay that we're on both sides of the line for right now. But now what we do is we divide the graph up. We say, okay, x minus 4 is only right on the right side of the line. So we erase everything on the left side. And we said that 2x plus 3 was only right on the left side of the line. So on the left side of the line, we leave everything for 2x plus 3. So we're going to use our closed circle here. And now we can erase our dividing line. So this is what our graph looks like for this piecewise function. Really, it's just dividing the graph into 2 and saying from this point to this point, we deal with this, and from this point to this point, we deal with this. So as long as you can graph both of them and identify where the graph changes. So right here, we look and we say, okay, 2 is the point that it cares if it's less than or equal to. So 2 is probably the point where it changes. This is going to be that point. So you draw that line on whatever it is. It's a horizontal line, or I'm sorry, a vertical line always. So if it were 4, we would draw it 1, 2, 3, 4. And then we would have divided our graph in half by that line. Does this make sense? Guys, I've got to say something.
It does, but
We'll work another one.
I get it.
Okay.
It's not difficult. It's just that
Just the points. At the very beginning, is.
It's steps. I know.
But it's not bad. It's easy to catch it.
All right, we'll work this one a little simpler. So,
It's not bad, bro.
I know they're all bad, but they all look like that. So,
I like a chin.
all right, we'll do 2 and 4. This one will be a little simpler, but we're going to make this part more difficult. Okay, so this looks more difficult, but really we know how to handle it. We really need to identify each of these sections on the graph. So that's where I like to start, is identifying my sections. And up above, all we had to do to identify the section was just divide the graph in half. But here we actually have sections of the graph. They're 2 lines, they're portions, they're not the whole half of the graph. So if we identify -5 to -1, between -5 and -1, I'm getting that from right here, then we say, okay, -5 is 1, 2, 3, 4, 5. -5, I'm just putting a little line here just to mark it for myself. I'm not doing anything with the problem yet. And then we do -1, which is right here as well. Okay, so that's one section of my graph. And my other section of the graph is going to be from -1 up to 3. So I'm going to just use a dot right here, and then 1, 2, 3. And I'm going to use a dot right here. So our sections of the graph are pretty much this section and this section. So this is helpful. Now we can start by graphing what we need to graph. So we say, okay, for anything we plug in for x between these 2, we want 2. So anything we get, we're going to get 2. So we just say, okay, choose the answer. We graph 2 at every point. And then anything that we plug in between -1 and 3, well, for that, we get 4. So 2, 4. So now we have what we need. This is also called a step function because it kind of looks like steps. So now we need to do the open circle, closed circle thing. So we look at our -5 and we say, okay, this is going to be a closed circle for sure. So we close circle that one. And then this one is an open circle because we don't have the extra line. And then on the other one, we look at this and we say, okay, no extra line, so open circle. And then here we see closed circle. So this is what that graph looks like. And that means anytime we plug in anything between these two, it doesn't matter what our x is. Our x could be right here. Our x could be right here. It does not matter at all what our x is. We're always going to get the y value of 2. And anything between these two, whatever x value we plug in, we're going to get this. And you can think of this like, you say, okay, when in the world would this ever come up in real life? Well, in real life, think of like shipping rates at the post office. If you go to ship a box, they say anything that weighs 0 to 5 pounds, we will ship for $5. Well, if you think of this as pounds and this as cost, we say, okay, from this point, we'll say, I'm just using the example. So we'll say 0 to 5, it costs this much money, $2. And anything on the step above that, from here to here, costs this much money. So 5 to 10 pounds costs $4, so on and so forth. And this is a useful graph for looking at how things work that are not necessarily dependent on like a function themselves. They're not 2x plus 3. They are just, one number at certain points. So that's when these are useful, piecewise functions or things like that. So one more example, and then I'll let you guys go.
Are you gonna be back in the afternoon?
No.
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 Can you check your email?
Yeah.
Okay.
If you need me, email me.
I'm going to finish doing my algebra and
Okay, so let's do 2x plus 3, 3, and 4x minus 5. And we're going to do these at -3 is less than or equal to x is less than 0. 0 is less than or equal to x is less than or equal to 2. 2 is less than or equal to x is less than or equal to 5. So I'm going to put my bracket. See, told you it's always terrible. And so now we go to graph this on a graph. And it's not any different because there are 3 points. It's still the same process. We just have 3 sections of the graph now. So we look at it and we say, okay, from -3 to 0. So we find -3, put a dot there. I'm going to put it in red. I'm going to color these by section. So -3 to 0. And then the next one will be in blue. So 0 to 2. And then we'll do the next one in green. So 2 to 5. 1, 2, 3, 4, 5. So these are our sections of the graph. We have the red section, the blue section, and the green section. So now we will graph each of these lines individually. So in the first section, we have 2x plus 3. So we go up 3 on our graph, 1, 2, 3. I'm going to put this in red just so it's visible. 1, 2, 3, and we put a dot. And then 2. Up 2 over 1, so a dot right there. Now we draw our line. And that's okay. So now we can pretty much erase anything outside of our section. So if it's not in our section, we do not need it. So it goes to right here, and it goes to right here. So we're good. We have that line in our section. Now we move on to the next one, which I did in blue. So we say, okay, this one is 3. So 1, 2, 3. So there we go. As long as it's in our section, we're good. So now we do 4x minus 5. So we graph this one in green. And I'm just graphing this just to make it clear for you guys. You can graph them each the same color and just erase when you're done. And that's fine. So we do minus 5. 1, 2, 3, 4, 5. And then up 1, 2, 3, 4 over 1. So dot right there. And line. So this one's going to have to go up forever and ever and ever for it to actually fall completely within our section, it looks like. But that's okay. So now we go back and we erase anything outside our section. So anything from here this way and anything from this little section this way. So now we go back and we add our points, or our dots. So for green, we're using a closed circle. We're using a closed circle again, because when we look up here, we see it goes with 2. And so we're using a closed circle on both ends of the 3 line. So I'm just going to go ahead and plug that in. Closed circle, closed circle. For the red line, we have a closed circle on the -3 side, but an open circle on this side. So closed circle right here. So that's how you do this type of problem, is you just take it piece by piece and deal with each piece independently. Okay, guys, that's all the time we got. So y'all have a good day.
You can